In this section, we'll look at conic sections in their general form, and after we look at how to identify them, we will look at how to complete the square to get them into standard form so we can find their key properties. So this equation in blue is the general form of the equation of a conic section. And we won't have all these pieces, but we'll have some of them, and we need to be able to pick out what we're looking for. Most of all, you're looking for the x squared term and the y squared term to see if they exist and which ones exist, or if both exist, and what their signs are in front of them. So that will tell us a lot. Now, we already talked about this in each individual conic section video, but we're going to just break it down in a summary here. So if the coefficient A and the coefficient C are the same sign, same number, everything's the same in front of the x squared and y squared, then that thing is going to be a circle. Then if ax squared or cy squared are missing, then if either one of those are missing, it's a parabola, because a parabola only has one of the two being squared, not both. And so I put specifically that if a equals 0, which means the x squared term would disappear. If a equals 0, that means there's only a y squared term, and that is your sideways or horizontal parabola, opening either to the left or the right. If c equals 0, that would make the y squared term go away, and you'd only have an x squared term, and that is a y equals x squared type parabola, which is kind of our original parabola that we learned, and that is an up or down parabola. So you're looking to see if the x squared is missing or if the y squared is missing, and then that will let you know it's a parabola and which type. Now, if a does not equal c, but the signs are the same, in other words, there's a plus in front of both of them or a minus in front of both of them, if the signs are the same, but the a and the c are different numbers, then it is an ellipse. So if a does not equal c, they're different numbers, but their signs have to be the same, or else it's going to be a hyperbola. So make sure the signs in front of the a and the c are the same. Then that makes it an ellipse. And then if a and c have different signs, then it's a hyperbola, even if it's the same absolute value number. In other words, if a and c are 3 and -3, that's still a hyperbola. It just they need to be two different numbers. Two different signs, but they can even be the same face value number. But they can be different as well. One could be 4 and one could be -7. It doesn't matter. It just, as long as they're different signs, that's what's going to tell you that it's a hyperbola. Now the b term, you'll never see at this level when you're first learning conic sections. The b term is an xy term, and that the b will be 0 in everything in this unit. And then as you get into calculus, you'll start having this b term kind of come into play. And what that does is it just makes a conic section that's not horizontal or vertical. It kind of goes at a slant. And so you can have an ellipse that's at a 45-degree angle instead of being straight up and down or straight sideways. And so that you'll never see, but I just wanted to show you what it was, because it is the b term, and I didn't want to skip and go straight from a to c without you seeing that. And then a lot of times we will have the x term and the y term, the d and e coefficients, but sometimes those will be missing, and if they exist, then you're going to complete the square with them, but if they don't exist, it'll make it even easier. And then f is always your constant, and usually when you're doing the conic sections, you'll move the constant to the other side of the equal sign, and you'll always have a 0 here when it's in general form, but eventually we're going to move that f over to that side and there'll be a number there. So that's kind of the general overview of the general form of a conic section. So here's our first example. So you look at what terms you have in general form and decide what kind of shape this is. And we know right off the bat that there is a y squared but there is no x squared. So this has to be a type of parabola. And what you are going to notice is since y is squared, we're looking at what I call an x equals y squared type parabola. And there's going to be an h and k and a and some other stuff in there, but this is a x equals y squared type parabola, which ends up being a sideways parabola, either going left or right. So we know that right away. So if that's the case, remember that that type of parabola ends up looking like the green standard equation at the bottom. And so that's what we're shooting for. So that helps to kind of visualize that so that you can know how you want to rearrange your numbers. And so our terms, what we want is we want our x term first. So we're going to put that first. Then if we have a plain number, we can put that next to the x. And so this is one of the only cases where you don't move the 45 over to the other side, because you really want it with the x term. And then we don't have to worry about a right now, but we're just trying to get the x's and y's on the correct side. And so we're going to move this guy over to the other side by adding a negative y squared to both sides, so you get negative y squared over here when you add it to the 0. And then you're also going to put this y term on the other side by adding 10y to both sides, so you get plus 10y. So those are all our numbers. We use the 4x and the 45, we use the y squared and the negative 10y, and got them on the correct side, so it will start to look more like our standard equation at the bottom. And so what we want to do is, first of all, we want to complete the square on this side, because anytime there's a y squared and a y, we have to complete the square. If there was just a y squared, we wouldn't have to, but we have to complete the square when there's a y squared and a y, or an x squared and an x. And so what we're going to need to do is we never can have anything in front when we complete the square. So we're going to have to factor out a negative 1 from that before we can start completing the square. And when we do that, we've got to make sure we compensate that on the other side in a little while. So when we factor out a negative 1 out of that binomial, we get y squared, and notice you'll get minus 10y, because you want this to distribute back to give you what you had at the previous step. And so that goes negative 10y, and then we're going to put our plus blank for completing the square. Then on the other side, we're going to put 4x plus 45 plus, and then we're going to put a blank here, but I always like to put, when we distribute this, we're not just going to add whatever's in the blank. We're going to add negative 1 times that as kind of added value to the right side. So we need to add that equivalent value to the left side to balance out the equation. So what I do sometimes is I'll put negative 1 times, and that way I'll remember to whatever I put in the blank, I'm going to multiply it by negative 1 to balance it out on the other side. So basically this number just gets accounted for right there when we multiply by the blank, which is the completing the square spot. So to complete the square, we always take half of the y term, or the x term if it was completing the square on the x, but here we're going to take half of the y term coefficient, and that is negative 5, and that is what we write in the next step, which is considered to be the factored step. We write y minus 5. Whatever half is, that's what goes there with the negative included. Then we take that negative 5 and we square it, and we write that number in the blank. And so what's in effect happening here is that this trinomial would have factored into y minus 5 and y minus 5. And that's why we chose 25 to be our completing the square number, because it will make this trinomial factor into those two orange factors, which we end up writing y minus 5 squared. So we don't write this step typically, but I just wanted to show you why it ends up being the y minus 5. But the shortcut is this will always be half of the previous step. And then we square it and put that number there. So I usually go in this order. I put half of -10 first, and then I square that number and put it up in the blank. Then, to complete the square, we have to balance that out by putting a 25 on the other side as well. But we didn't just add a 25 to the right side. We really added a value of -1 times 25 to that side. When we put that 25 there, we added value of -25, or -1 times 25, to that right side. And so that's why I put the -1 here, so I wouldn't forget about it. And so what we have over here is 4x plus 45, and then that's minus 25, or plus a -25. Then we have equals, and then we put this -1 comes down to the next step as well, and then we have this step here. When we put these two together to simplify, we get 4x plus 20 equals -1 y minus 5 squared. Now we're almost there, but notice this term here does not have anything in front of the x. It does not allow for any number or coefficient in front of the x except for a 1. So we're going to have to factor out a 4. I didn't want to do it up here because it doesn't factor out nicely. I wanted to wait till this step to factor out a 4. And so we're going to factor out a 4. And the reason we factor out a 4 is so that we can divide it out. So we're going to divide out a 4 and divide out a 4. And now you can see that what happens is our a ends up being -1/4. And then these cancel down to a 1. And so we end up with x plus 5, which is our x minus h, equals -1/4 y minus 5 squared. Now it is in standard form, and we'll be able to pull off any key information that we need off of that. So I'm going to circle that equation. That is our equation in standard form. If you have a teacher now or in the future that would rather you have it x equals, all you have to do is move the 5 over to the other side, and you can write a -5 after the end of the right side equation. So you could say x equals -1/4, then y minus 5 squared, and then put -5 at the end. So you can always move that number over at the end, but I like to keep my x and h together and my y and k together whenever possible, just because then I can read off my center, vertex, whatever it is, really quickly. And then all my conic sections kind of look the same. On the next page, I'm going to write out how this would look if the parabola had the x being squared. And I'll just give you another example to look at, but I'm not going to explain it. So just follow the steps if you'd like to. In this equation, because you only have an x squared and no y squared, this is a y equals x squared type parabola. So our goal is to get it in the bottom form in green, which is the standard form. And this will be either an up or down parabola. So this one was a tiny bit easier because we didn't have anything in front of the y, and so here is our final equation. We're going to do more on a part 2 of this video, so check it out.